If you ever think of buying good quality meat at unbeatable price, think Magilac Butchers, your only suitable solution for quality meat for you and your family consumption. Our comprehensive range of meat products include minced meat, beef slices, top side, knuckle, rump steak, silver side, tenderloin, strip loin, and forequarter. We offer consistent value, quality, and service through animals grass-fed and bred especially for their meat. This makes the meat much more tasty, succulent, tender, and easy to cook. All meats at Magilac Butchers are halal, including for the first time in the Gambia, the new Mongolian whole lamb, available only at Magilac Butchers. Rush now and visit Magilac Butchers on Caraba Avenue, opposite the Petrogas petrol station traffic lights. For inquiries and orders, please call 7688-688. That is 7688-688. Magilac Butchers, the home of quality meat and chicken products at unbeatable prices.
That the last time he sent the money, it was not enough to buy all the provisions.
Oh, sorry, I forgot to tell him.
Are you guys talking about money transfer to buy provisions?
Yes.
But don't you know about Baluwo?
Baluwo? What is Baluwo?
Baluwo is a service that your son can use to send provisions directly to you guys from the shop. And you don't have to worry about the exchange rate.
Tell me how Baluwo works.
It's very simple.
Just log on to baluwo.com and shop, or download the app on your phone. You can shop on the website or using the app to buy online basic products for your family and friends. With Baluwo, you decide what your money is spent on. Your money, your choice. Buy online products for your family and friends in the Gambia, Senegal, Nigeria or Mali. Baluwo, better than sending money.
Hi, my name is Buba Gajigo and you're watching Kerr Fatou. This is your educational program and now we're gonna bring you lessons from senior school. If you have your kid attending senior school, get them prepared and I hope you enjoy these lessons.
Are you thinking of owning your dream homes? EJ Investment is here for you. Secure our quality bungalows with 2, 3 or 4 bedrooms or our story buildings 3 or 4 to 5 bedrooms at very affordable prices with flexible payment plans at our Sanyang Seaview Estate where you can enjoy the cool breeze with modern infrastructure such as tar roads, covered drainage system, modern electrification with street lights, gated entrance with security posts, and social amenities such as gas station, shopping mall, medical clinic, park, schools, children daycare, and a lot more. Our dedicated team of professionals will keep the estate clean at all times, provide security and patrol team within the estate premises, install latest technologies such as CCTV, Wi-Fi, home network installation, solar panel, and power backup system. Also, check out for our additional home facilities and interior design service such as premium tiling, wall plaster, home landscape, fingerprint home lock, and a lot more. Visit our office at Senegambia Kololi Highway and get a free site visit tour or contact us on 4464-838. WhatsApp us on 3259220. Or you can visit our Facebook page or Instagram on EJ Investments. EJ Investments, we are first in properties.
Hello viewers, these are key messages from the Ministry of Basic and Secondary Education on the coronavirus. Dear parents, keep children at home at all times. Avoid sending children to shops and markets. Do not engage children in petty trading on the streets and garages. Allow children to play within the confines of the home. Limit visitors into your homes. Adhere to COVID-19 health precautions and guidelines. Schools are closed, but learning continues. Dear teachers, you are encouraged to desist from all forms of group activities involving students. All school premises should remain closed and not to be used for any other purpose. Thank you.
Hi everyone. I am Mr. Babukar Au, your chemistry tutor. And today, our lesson will be based on chemical bonding. And then we will follow these contents. That is, first of all, we will first start with the review of the periodic table. Because everything that we are going to do today will be based on the periodic table. Now again, we will discuss about chemical bonding, and then we move into ionic bonding. And this ionic bonding now is going to be the main topic of this lesson. And again, we will discuss about the properties of ionic compounds, and also we will discuss on predicted and ionic compounds formula. That is how ionic compounds formula can be predicted. And also, we will discuss about naming of ionic compound. Now here, we said the periodic table is periodic. That is periodic because of certain trends that are seen in the elements. That is, there are certain trends that normally repeat themselves in the periodic table at a regular interval. That's why we said the periodic table is periodic. Now, some of these trends can be seen in the properties of the atoms like. That is, these trends that normally repeat themselves in a regular pattern. One of them is atomic size. We also have ionization energy, electronegativity, and also metallic character. But then these are not the only periodic properties we have. We also have other periodic properties. Now, I have a question for you guys. That is, will you predict that elements from the same family or group will have similar physical and chemical property? So think about that, and then you find a solution to this question. But by the way, I know that this one, the answer will be somehow simple. Now, we have metallic character of elements. Now, the periodic table is composed of what? Metals and also what? Non-metals. You have metals in our left side, and also we have non-metals in our what? Right-hand side. But then the metallic property will increase from the non-metals to the what? Metals. and also the metallic character will decrease from the metals to the what? Non-metals. Here, when discussing about metallic character, you should not consider how strong the element is, because we said metals can donate what? Electrons. So the easier the element donates its valence electron, the more metallic it becomes. For example, if we want to compare lithium, sodium, and also potassium, of course we know lithium is having 1, 2 cells. Sodium is having 1, 2, and 3 cells, while potassium is having 1, 2, 3, 4 cells. They all have the same what? Valence electron. That is, all of them are having single electron on their last cell. So here, there is a force of attraction between the positive nucleus and the valence electron. That is in these 3 atoms. So we can see that this potassium, the valence electron is very far from the what? Protons. So the charge here will be somehow less, which means potassium can easily what? Lose its electron. You come to what? Sodium. Comparing sodium and potassium, potassium will be what? Readily donate its valence electron than what? Sodium, because potassium has what? More cells, that is more what? Sealing effect. Again, if you want to compare lithium and sodium, can easily what? Sodium can easily what? Donate its valence electron than what? Lithium, because sodium has more what? Cells. So if you have more cells, there is what? Less effective nuclear charge. And when the effective nuclear charge is less, the elements will tend to what? Or easily donate their what? Their valence electrons. So here we can say potassium is more metallic than what? Sodium. Sodium also is more metallic than what? Than lithium. So which means the bigger the atom, when these atoms are in the same group or the same family now, the more metallic it becomes, because they can easily donate their what? Their valence electrons. That is, what is the relationship between metallic character and effective nuclear charge? Are they directly or inversely what? Related? With this explanation, we can answer this question. That is, metallic character and effective nuclear charge are inversely related. Is it accurate to say element A is more metallic than element B, even if element B is a non-metal? I will leave this question also for you guys to answer. Now we have the periodic table down. That you see, we have the right side and also the left side. Where on top of the left side we have more metallic. That is where you have what? The metals itself. Now in between you have less metallic, and on your what? On your right side you have what? The non-metallic, or that is the what? The non-metals. And then we will just discuss about elements that is from group 1 to group A, and also maybe some of the what? Transition elements. So always we see this diagram, that is metallic character will always increase from the non-metals to the metals. Now we have some sample questions here that we are to answer together. And the one reads, in the periodic table, the elements are arranged in dash. A, alphabetical order. B, order of increase in atomic number. C, order of increase in metallic properties. D, order of increase in neutron content. E, reverse alphabetical order. And F, I don't know how to answer this question. Now when we look at these options, that is from letter A to F, we realize that B is the correct option, and that is order of increasing atomic number. Now question 2 says, element does exhibit similar physical and chemical properties. And we have A, similar chemical symbols, B, similar atomic masses, C, in the same period of the periodic table, D, on opposite sides of the periodic table, and E, in the same group of the periodic table. And here we have the correct option as letter E. Now we move to number 2, and it reads elements that exhibit similar physical and chemical properties. It's A, with similar chemical symbols, B, with similar atomic masses, C, in the same period of the periodic table, D, on opposite sides of the periodic table, and E, in the same group of the periodic table. And here, when we look at these options, we know that elements that have similar physical and chemical properties must come from the same group of the periodic table, which means letter E is the correct option in number 2. Now, number 3, which pair of elements would you expect to exhibit the greatest similarity in their physical and chemical property? Now, to summarize this question, the question is actually asking us which pairs are in the same group. Because the previous questions, the way we answered it, we should know that elements from the same group will tend to have the same or similar physical and chemical properties. Now here A, we have lithium and sodium, B, cesium and barium, and C, calcium and silicon, and D, we have gallium and germanium, E, we have carbon and oxygen. And then in this case the correct answer is A, that is lithium and sodium, because they all have valency of 1, 1. Number 4, potassium is a dash and chlorine is a dash. Potassium is a dash and chlorine is a dash. A, metal and non-metal. B, metal, metal. C, metal and metalloid. D, metalloid and non-metal. E, non-metal and a metal. Now in this case we know that potassium is found on our left side of the periodic table, which means potassium is a metal, while chlorine is found on the what? Far right on the what? Periodic table, which means it is what? A non-metal. And in this case our correct option is letter A. Now we have chemical bonding. Chemical bonding. Now, sometimes we misinterpret this word, that is chemical. Anyone who hears this word chemical, they term this word to be what? A dangerous substance. Actually, chemical means something that involves what? Electrons. Something that involves electrons. Chemical does not mean something which is what? Harmful. The water we are drinking is a chemical. And we are drinking what? The water every day. But it doesn't mean that the water we are drinking is what? Is harmful. It is chemical because it involves what? Transfer of electrons. Now, we said chemical bonding, this is the chemical combination of two or more what? Particles. Two or more particles. And our particles could be one, ions, could be also what? Atoms, and also could be what? Could be what? Molecules. So our particles could be what? In these three forms. Now when they combine, we say the process is called what? Bonding. Now we have some points also. And point 1 reads, all chemical bonds involve the what? Valence electron. Now for example now, we have an element like Na. We know that the atomic number of Na is what? 11. And here, the all electron configuration is going to be what? 2, 8, 1. So, although the electrons will take part in the bonding, but not all the electrons will what? Will participate in the what? In the bonding. But only the electron on the what? On the large cell will what? Will participate in the bonding. And they are called valence electrons. A chemical bond is a strong force of attraction holding atoms in a molecule or crystals together. That is, it could be what? The bond between what? Between molecules and also what? Crystals like what? Solid particles. So the bond that holds this kind of substances is all what? Bonding. Again, generally, bonds between atoms in their atomic or ionic forms are stronger than those between what? Molecules. Because, for example, if I use something like this kind of models, I have this. Now, I can have here NaCl, Na what? Cl. So you see now, inside this molecule now, I have what? Na and what? Cl minus. Inside here I have what? Na and what? Cl minus. That is Na plus and Cl minus. Now, it is saying that the bond between this sodium and this chlorine is far stronger than what? The bond between this molecule of sodium chloride and this molecule of what? Sodium chloride. And again, if you use water as sample, you can also have the same thing. That is, you can have here H2O and here H2O. That is again the bond between inside or between this hydrogen atom and this oxygen is far stronger than the bond that holds this molecule of water with this molecule of water. That's why whenever you boil water, this bond will what? Will break. But not this bond between the what? Hydrogen and the oxygen inside the molecule itself. Now, energy changes occurs during what? Bond formation. Yes, we have energy what? Energy changes. And also, whenever a chemical reaction is taking place, we have what is called bond breaking and also what? Bond formation. When there is bond breaking, you must have energy change. When there is bond formation, you also have what? Energy change. Now, the overall energy changes make this bond a final substance which is more what? Stable. That is the energy change in the bond breaking, that is A plus B to give us what? C. So when A and B are reacting to form this C now, there must be what? Energy change. So the energy change that involved in the combination of these two now will form what? A more stable species. A more stable what? Species. Because energy is gained or what? Or lost. And also we have, where do atoms or particles bond? Yes, we said bonding is what? The chemical combination of ions, atoms or what? Molecules. Why are these atoms or ions or molecules bonding? Where do atoms or particles bond? We should know the reason. And here it says, atoms bond in order to attain a stable doublet or octet what? Structure. Doublet or octet what? Structure. Now, doublet and what? And octet. Now, you will have doublet when your valence electron can obtain a maximum of what? 2 electrons. And you can have an octet structure when your valence electron can have a maximum of what? 8 electrons. So all atoms bond to have what? A doublet or what? Or octet structure. And this will lead them to what? To their what? Nearest inner gas structure. Now a doublet structure is a stable electron configuration of 2 electrons in the valence shell of an atom. That is 2 electrons in the valence shell of an atom. And also an octet structure is a stable electron configuration of 8 electrons in the valence shell of an atom. Now again we have, how do atoms bond? How do atoms bond? We need to understand how do atoms or particles bond. That is, atoms bond mainly by 1. Losing or gaining of electron resulting in ionic bond formation. Losing or what? Gaining. That is, we have metals and also what? Non-metals. So you see, when metals are bonding, they can only what? Lose their what? Their valence electron. So in this case, metal can bond by what? Losing their what? Valence electron. Well, non-metals can also bond by what? By gaining what? Electrons. So whenever a metal and a non-metal are bonding, then the metal will what? Will donate, and this non-metal will what? Will gain. And then when this donate and this gains, they'll form what is called what? Ionic bond. And when this metal donate, it becomes what? Positively charged, and this gain, and it becomes what? Negatively charged. That's why we said it is called what? Ionic what? Bond. Because it is what? Electrostatic force of attraction that involves the what? The ions in the crystal itself. Other atoms bond by sharing electrons, resulting in covalent bond formation. We said non-metals can only what? Gain electrons. But non-metals can bond. That is, one non-metal can bond with what? Another non-metals. Now they do this kind of bonding by what? By sharing. And now when sharing, they will bring equal number of what? Of electrons. If non-metal X uses or brings 2 electrons, non-metal Y also will what? Will bring 2 electrons, so that they will all attain stability. Other atoms also bonds by what? Freeing or delocalizing electrons, resulting in metallic bond formation. Example, magnesium metal. If you have a metal like this, and then we say this metal is made of what? Or is what? Is magnesium. Now, which means we have several atoms of what? Of magnesium. Now, these magnesium atoms now are bonding using their what? Their valence electron. That is, they are freeing their what? Their valence electron, so that information will be transferred from one atom to another atom. From this atom to this atom. From this atom to this atom. At the end, we said what? The electron is what? Delocalizing. That is, electron is what? Moving from one atom to another. Now, we also have what? Types of what? Bonding. Now, generally, we have 2 main types of what? 2 main types of bonding. That's generally, yeah? And the first bond we have is called interatomic bond. Interatomic bond. And this is the bond or the force of attraction between atoms of a molecule. And the examples are: 1, we have ionic or electrovalent bond. 2, we have covalent bond. And 3, we have coordinate or coordinate covalent or dative bond. And then this coordinate or dative bond is a type of covalent bond in which the electrons needed for bonding is donated by a single atom. And again, we have metallic bond, and also this is the bond that takes place in metals and also in some of the alloys. The other type of bond is called intermolecular bond, and this intermolecular bond is just what? A weak force of attraction between what? Between molecules. And then the examples are, we have hydrogen bond and also van der Waals forces of attraction. That is, generally, the interatomic bonds are stronger than the what? Intermolecular bonds. Intermolecular bonds, all of them are weak, but hydrogen bond is the strongest in this kind of bonds. Now we have the formation of what? Cations. For example, we have a neutral atom of Na. We know Na is having what? 11 what? Atomic number. That is, atomic number is 11. Which implies the proton numbers, the proton is 11. The electrons also is what? 11. Because in this case, the atom is neutral. Now, when this sodium now loses an electron, we will have something like Na plus an electron. Because now, still now, the protons will be what? 11. Because proton numbers do not participate in what? In bonding. Only electrons do. And here the electron number now will be what? Will be 10, because one of the electrons here is been what? It's been donated, and then it becomes what? Plus 1. Or you can say now, since the electron is negatively charged and the protons are what? Positively charged, you can simply say 11 minus what? Minus 10. And at the end you will have what? 1. But this one is what? Is positive 1. That's why the charge of sodium here is what? Is plus 1. That is, this is the formation of what? Of cations. Again, we have the formation of what? Cation still. Maybe we have another element like magnesium. We know that the valence of magnesium is 2 electrons. Now in this case I'm using the Lewis dot structure. Now this can form Mg 2 plus what? 2 electrons. This is neutral. We'll have the proton numbers in this case will be what? 12. And the electron numbers in this case will be what? 12. Because the atom is what? Neutral. But then when the magnesium donates 2 electrons now, you'll still have the proton numbers as what? As 12. But then the electrons number becomes what? This means it has donated what? 2 electrons. So here we'll have what? 10. Still now, you say 12 minus what? 10, and then you'll have what? 2. But this 2 is what? Number of protons. It means you have 2 more protons than the what? Electrons. That's why we say it's plus 2. And here we have Mg as plus 2. And this thing is applicable to all what? To all the metals. We also have formation of what? Of anions. Formation of anions. Now, if you have anions like chlorine atom, because we know the atomic number of chlorine is 17, it means the neutral form now, the proton number is going to be what? 17. And then the electron number is also going to be what? 17, because the atom is what? Is neutral. Now, we will have Cl minus in this case. And here we have plus what? Plus an electron. Here we have minus. But the proton number is still going to be what? 17. But now the electron number here, it means this chlorine now, it was neutral and it has received 1 more electron. The electron number here was 17 and now it has received 1 more. Now it becomes what? 18. So now you see we have 1 more electron than the what? Than the protons. Now in this case we can say 17 minus what? 18. And now in this case we know that it's going to be what? Minus 1. That's why the charge of this chlorine here is what? Is negative 1. And this is applicable to all the non-metals. Now we have again some sample questions. And number 5 reads, anions tend to be dash and cations tend to be dash. That is A, metals and metals. B, non-metals and non-metals. C, metals and non-metals. D, non-metals and metals. And again we have E, metalloids and metalloids. Now we know anions are what? They are non-metals, while cations are from the what? Are from the metals. Which means our correct option here is going to be letter D. Which means anions tend to be what? Non-metals, while cations will tend to be metals. Number 6 reads, metals lose electrons to form cations. True or false? When metals lose, their charge becomes positive. That is, they'll form what? Cations. Is it true or false? Of course, yes. It is true. So which means the correct option here is true. 8. This is the ion formed from a calcium atom. This is the ion formed from calcium atom. And A is calcium plus, that is Ca plus, and B is Ca2 plus, and C is Ca minus, and D is Ca2 minus. You know the symbol of calcium is Ca, and the atomic number of calcium is 20. We know that the old atomic configuration now, we can write this as 2, 8, 8, 2, which means it is easier for calcium to donate these 2 electrons than to accept what? 6 electrons. And calcium also is what? It's a metal, which means it must donate these 2 electrons. That is, you will have first ionization energy and also what? Second ionization energy. That's the removal of the first electron and also after the removal of the what? Second electron. Which means the correct option in this case is letter B, which is Ca2 plus. Number 9. Phosphorus forms an ion with a charge of dash A plus 1, B minus 2, C plus 3, D 3 minus, and then E plus 2 or 2 plus. That is phosphorus is atomic number 15. And in this case, we know that the atomic configuration is going to be what? 2, 8, 5. 2, 8, 5. And know that this 5 now is more than 4, which means it is easier for this phosphorus now to gain 3 electrons so that it will be stable than to lose all these 5 electrons. And then when you gain, you will tend to have what? A negative sign. And then you have 5, 6, 7, 8. That is, you have 3 more after this 5 to have what? An octet structure. Which means the correct option here is going to be letter D, which is 3 minus. We have ionic bonding. Ionic bonding. Now here we also have introduction to the chemical bonds. That is, we have 3 basic types of bonds. But again, all these basic types of bonds are all types of interatomic bonds. That is, 1, we have ionic, which is electrostatic attraction between the ions. And then covalent is the sharing of electrons between atoms. And also metallic is each metal atom bonds with the other metals within a sea of what? Within a sea of electrons. Now, we look at ionic bonding. Ionic bonding, yeah? But we still have a review of the types of bonds also. Now we said we have 3 types of bonds. That is, 1, we have ionic bonds, which is the electrostatic attraction between ions, and also we have covalent, that is the sharing of electrons between atoms. You also have metallic, which also involve other atoms within a sea of electrons. That is, they allow the free flow of their valence what? Electrons. That is, the metals, their electrons or the valence electrons are delocalized. Localized. Now, we have ionic bond. Ionic bond, and this ionic bond involves a complete transfer of electrons from one atom, usually a metal, because now we know that metals will what? Will lose. Metals will what? Will transfer their what? Their electrons. That is, to another atom, usually a non what? A non-metal. Which means non-metal, they tend to what? Receive electrons. But this thing happens so that they will both attain what? Stability. That is, both the metal and the non-metal will finally attain stability. Electrons are lost by the electropositive element, which is the what? The metal. And gained by the electronegative element, and that is the what? Non-metal. Non-metal. Now we have some points down here, and number 1 reads, metals become positively charged cations by losing what? Electrons. Now you see, if you have the same sample that we are using Na. This Na now can form Na plus what? An electron. It means this sodium now loses 1 electron and it becomes what? Positively what? Charged. Non-metals become negatively charged ions by gaining what? Electrons. If we have Cl, and now here we have Cl minus, this is plus what? An electron. Now you see here, the Cl will gain 1 electron and it becomes what? Cl minus. Now the electrostatic force of attraction between cations and anions result in ionic bond formation. Now that is the electrostatic force of attraction between this sodium ion and this chloride ion now result in the formation of what? Of ionic bonding. That is, you can have something like this, Na plus and Cl minus. This plus 1, still 1. This minus 1, it is still 1. Now these ions now are playing the role of what? Of valences. If you exchange, you still have NaCl. That is, this positive charge and this negative charge now will result in the formation of what? An ionic compound. That is, the attraction between this and this also is called electrostatic force of attraction. Now we also have what is called electrovalency. Now the electrovalency of sodium, is 1 because sodium lost a single one electron. Again, the electrovalency of chlorine is 1 because chlorine receives what? A single electron. So electrovalency can be the number of electrons transferred or the number of electrons received in this kind of reactions. Now we have formation of ionic bonds. And in this case, I will use the molecular structure of these compounds and then we will draw their bonding. That is, on the board we have an element, and then this, or the first element, is a neutral atom which is having 1 valence electron, and also the electronegativity is low. Now the next atom also is also a neutral atom with 7 valence electrons with high electronegativity value. Now these two, they will be what? Easy attraction, because the atom with the high value, that is with the high electronegativity value, will tend to attract the electron from the atom which have low electronegativity value, and this will result in the formation of ionic compound. Now we can have Na, we say it is 11, and here we have 2, 8, 1. This is 1, 2, 3, which means we should draw 3 cells. That is, we'll have 1, 2, and 3 cells. Now, the first cell here will carry 2, the second cell will carry 3, and then the third cell will carry 1. And here we will just show what? The electron in the valence shell. Again, we have this side, something like fluorine, and then we know fluorine is 9, and in this case it's going to be 2, 7. 2 plus 7 will have 9, and this is 2, or this is 1, and this is 2, which means we just need what? 2 cells. That is 1, 2. So the valence cell of this fluorine now becomes, or the valence electron of this fluorine now becomes what? 7. We will have here 1, 2, 3, 4, 5, 6, and here we have 7. So you see now, this fluorine now is having high electronegativity, and this is having what? Low electronegativity. So transferred to this one. Or you can say this element with high electronegativity value now will easily what? attract the electron on the what? Atom with the low electronegativity value. And when this happens, this will move here, and then you have Na plus. And then this will receive, and then we'll have F minus. So the force of attraction between this and this now will result in the formation of what? Of ionic compound. Now we also have, or still on the ionic bond, we said the atom with the high electronegativity attracts valence electrons from the atom with the low electronegativity. That's the same thing that happens here. So this one is having higher value when it comes to electronegativity, so it will easily what? Attract the valence electron from the one with the what? Low electronegativity. Now when the atoms become positively charged ions, the electrostatic force of attraction brings them together. That is, the electrostatic force of attraction will hold this positive charge and this negative charge together, and this will result in the formation of a stable compound. Now also we still on this ionic bonding. Compounds composed of cations and anions are called ionic what? Compounds. Any compounds you see, and you know the compound is having something like what? A cation and a what? Anion. You know the compound is called what? An ionic compound. And these two will result in the formation of NaF, that is sodium fluoride. It's a binary compound because we just have what? Two atoms. Now although they are composed of ions, ionic compounds are electrically what? Neutral. Yes, they are electrically neutral, because you see now these charges now will cancel each other, and then when they form the compound will be what? The compound will be neutral. Now the electrostatic force that hold ions together in ionic compounds are called ionic bonds. That is, the force of attraction between this positive charge and this negative charge now is called ionic bond, and the compound itself is called ionic compound. Now here we have the electron transfer process in creating an ionic bond. That is something like this. Here we have sodium and fluorine, which results in the formation of sodium fluoride, and here we have sodium and chlorine, and this will result in the formation of sodium chloride. Now we have ionic bonding still. Now we have a periodic table in this case, and this periodic table now is showing us the electronegativity value of different kind of atoms or elements contained in the periodic table. Now this ionic bonding, we have a value which is 1.7. Now if you are given two atoms, and then you know the electronegative value of these two atoms, you subtract their values, and then you have something like 1.7 or more than 1.7. That compound is pure ionic compound. But if you subtract and then you have something below 1.7, and then we say that compound becomes what? Or that compound will be likely to become a covalent compound. So in all cases, ionic compounds, the difference between the two combining atoms must be 1.7 or more than 1.7. And sometimes when questions are asked regarding these things now, the values of these atoms are given. That is, we can find out from this periodic table now, sodium is having a value of 0.9, while fluorine is having a value of 4.0. This is Na, and this is what? And this is F. Now if you subtract 4.0 minus 0.9, you will have something like 3.1. Now you see the difference between this fluorine and the sodium is what? 3.1. And 3.1 is more than what? 1.7. Which means this compound is more ionic than what? Than covalent. Now we still have, or we have some questions again that we are to answer. And the first question reads, which pair of atoms will form an ionic bond? Lithium and neon. B, potassium and bromine. C, potassium and cesium. And D, sulfur, and chlorine. Now, when you look at these pairs of electrons, you will know that you only have in letter B metal and a non-metal, that is potassium and bromine. Now, when they react, they will form an ionic bond, because the potassium will donate its electron to the bromine, and the bromine will accept its electron. 11, that is second question. Which pair of atoms will form an ionic bond? Still, which pair of atoms will form an ionic bond? Lithium and beryllium. That is A, lithium and beryllium. They are both what? Metals, so they cannot form ionic bond. B, sodium and magnesium. Sodium is in group 1, magnesium is in group 2, which means they are both what? Metals, so they cannot form ionic bond. C, we have potassium and calcium. Potassium also is in group 1 and calcium is in group 2, which means they are both what? Metals, so they cannot form ionic bond. And D, sodium and chlorine. That is, sodium is a metal and chlorine is a non-metal, which means the correct option here is letter D, which is Na and Cl. 12. An ionic bond will form between scandium and fluorine. True or false? Scandium and what? Fluorine. Of course, scandium is the first transition metal, and fluorine also is what? A non-metal. So when they react, they will form an ionic bond, which means here it is true. 13. Which of the following compounds will you expect to be what? To be ionic? A, water. B, CO2. And then C, strontium 2 chloride. And then D, sulfur 4 oxide. And E, hydrogen sulfide. So the correct option here is C. Now we have factors influencing the ionic bond formation. Yes, we know that metals and non-metals, whenever they react, they will form ionic compounds. But what are the factors that will influence the formation of these ionic compounds? That is, 1, we have electron affinity. Electron affinity. Now, this affinity now simply means what? The love for what? Electrons. There are certain atoms, they are in the periodic table. They like what? Electrons. When they see electrons now, they will tend to what? Attract those electrons. So they have affinity towards what? Towards these electrons. Now, it says non-metals with high electron affinities form stronger ionic bonds readily. That's whenever. Now, the first factor here is electron affinity. Now, we said non-metals with high electron affinity, when they react with a metal with low electron affinity, they tend to form a strong ionic compound. That is, the non-metal will have high electron affinity, while the metal will have low electron affinity. When they react, they tend to form a strong ionic bond readily. Now, 2, ionization energy. And here, ionization energy simply means what? The removal what? Of electrons. That is the energy needed to remove 1 mole of what? Electrons. Now, metals, they tend to what? Lose their what? Their electrons, which means metals, they have low ionization energies, while non-metals, they want to what? They always receive electron. So it needs great energy to remove electrons from the what? Non-metals. So whenever a non-metal with high ionization energy, that is a non-metal with high ionization energy, reacts with a metal with low ionization energy, they tend to form a strong ionic bond readily. Strong ionic bond readily. And also we have electronegativity. Now, if you are given 2 elements, now maybe you are given a metal and also what? A non-metal. And then you are given the values. For example, you have something like 0.9 here, and here you have what? 4.0. Now, We said if you subtract the difference between these two and then you have something like or something more than 1.7 or 1.7 exactly, we said the compound is what? Is more ionic. But then the greater this value, that is the higher this value or the higher the difference between the metal and the non-metal, the more ionic that compound become. That is, if you subtract, maybe in compound A, the difference is just something like 2.0. In compound B, the difference is something like 2.5. Now, we can simply say that compound B is more ionic than compound what? A, because the difference is higher in compound B. Now note, generally, ionic compound or ionic bonds formation is favored between an element with low electronegativity and a low ionization energy and another with high electronegativity with high electron affinity. Now you see this high is always associated to the what? Non-metals, while the low is associated to the what? To the metal. So whenever a metal and a non-metal react now, they tend to form a strong ionic compound. Now we also have properties of what? Of ionic compounds. One, we said they are crystalline solid at room what? Temperature. Now we can see these structures, that is the models down, and they are all trying to explain what? The crystalline structure of these ionic compounds. Now sometimes we will say that they have a lattice what? A lattice structure. Lattice structure, that is a three what? Dimensional arrangement of the molecules in what? In their crystalline form. Now again, they have high melting points and also what? Boiling points. That is, whenever a metal and a non-metal react now and they form ionic compound now, the compounds will have what? High melting and boiling point, because the force of attraction there, which is electrostatic force of attraction, will be very, very strong. Yes, and finally, they conduct electricity when melted or when they are in molten state or when they are dissolved in. If we have NaF solid, there are ions, but the ions are not mobile. The ions cannot move. So in this case now, they cannot conduct electricity. But then if we have NaF in aqueous solution, which means now the Na plus will exist in the solution and the F minus will exist in the what? In the solution. So now the movement of these two ions now will carry what? Electricity. That's why we said ionic compounds now, in their molten or aqueous solution, they conduct what? Electricity. And finally, we have predicting an ionic compound formula. That is, we have a potassium, that is K, which is a metal with an electronegativity of 0.8, and oxygen, which is a non-metal, with an electronegativity of 3.5, will form an ionic compound. What is the formula for an ionic compound of potassium and oxygen? That is, one, we have K for potassium and O for what? Oxygen. Now we know that the valency of potassium is 1 and the valency of oxygen is 2. So we'll have something like this, that is K2O. Now, how many additional valence electron does oxygen need? How many valence electron or how many additional valence electron does oxygen need? Now in this case, oxygen needs an additional of what? Of 2. And potassium can only bring what? 1 electron. That's why we'll use 2 atoms of potassium will bond with what? A single atom of what? Oxygen. Which means oxygen needs an additional of what? Of 2 electrons. Now, how many electrons does potassium have? How many electrons or how many valence electrons does potassium have? Potassium is having what? A valence electron of what? Of 1. How many atoms or how many potassium atoms will it take to give oxygen the electrons it needs? If the valence electron of potassium is 1, therefore potassium needs to come with what? With 2 atoms. And these 2 atoms now will satisfy 1 atom of what? Of oxygen. Now the metal is always first and then the non-metal is second. That is, when you are writing an ionic compound, that is a formula of anything which is Ionic, you must write the what? The metal, and then after you write the what? You write the non-metal. So with this, we come to the end of the lesson. Hope to see you in our subsequent videos.
Hello viewers, these are key messages from the Ministry of Basic and Secondary Education on the coronavirus. Dear parents, keep children at home at all times. Avoid sending children to shops and markets. Do not engage children in petty trading on the streets and garages. Allow children to play within the confines of the home. Limit visitors into your homes. Adhere to COVID-19 health precautions and guidelines. Schools are closed, but learning continues. Dear teachers, you are encouraged to desist from all forms of group activities involving students. All school premises should remain closed and not to be used for any other purpose. Thank you.
In communication, connectivity is everything. We ensure that the links never sleep. Quantities and qualities, all in our data service, providing efficient, reliable voice and data service. We believe if you're not up to speed, then you're going backwards. Communications have to flow as fast as the speed of light. Whatever business you're in, having someone who understands your needs is critical. That is why we just don't offer you technology, we offer you solutions. Enjoy Gamcel's internet broadband anytime, anywhere. Your national operator, Gamcel, Yaibaram.
I get it. Albaka.
Mbaka important.
Yo, nga transfer la sto.
Ya transfer la sto.
Ha, code nyenji.
Okay.
Code sana.
Nsila ID soto.
Ha, sa soto. Sorry. I get it.
Bijan bro.
Albaka.
Mbaka.
Bara alla service o tariya.
Ha,
mbale. Mo ki janna nun kunu bara tariya.
Jannom yona forest de bureau. Gambia tonkon na no mbali ya bere. Ha. Birim koyna fo kato.
Bari si kodo kino kato ni fo bolong blabe to.
56 branches mola soto Gambia jang.
Ha?
Ha. Gambia kono anin Gambia bantala bankol. Nka kono kiya bele. Kodo sifa fo falindiro fo nyaadi lafta memmen na kodi to poto nin kodi maraw. Jannam number 1 di nyonta. Andum fana nata anoda enterprise sotale. Wolam nyindi ko domorol fana kol fana be firale le dadi ma nin domorol nin fana beteat. Gambia dawda yalo ngam fa kendol sotale je.
Ha e wo moyo diat ha.
Apelenta
ni wo ka ni lafta nyelen kendol e bina.
Yalo bu kanyi la ko la baraka ba.
Yalo ndel chosano lo.
Abaraka.
broke down.
With Gamtel G-Fiber, now you can enjoy super fast internet in gigabytes. G-Fiber is affordable, stable, secured, and accessible to homes, businesses, and enterprises. With Gamtel G-Fiber, the future is speed. Gamtel, creating a brighter future in communication.
That's how she became mine and see the
Yara nyilla domoro kadiyata.
Boy, janno Sikes restaurant.
Sa nako be ninna dimbal. Nimba domoro kala janno.
Domoro seneyata adiyata topotoro fanan kende ma bije. Luntan during tamala abeka domoro kijani. Adi manda wala de. Teka we bijele anim fanan ka fadi jang ikono e fa. E ka fa minne ko pastry anim bakery. Iko fanan bekalele. Badde lomba conference lomba workshop lomba ye fo pendin lo dunia kono domoro betama nyillom international o tewoda number 1
amanke ba domola jandam man
esa domo jang is atariya
wo mu kubandi
sa nako sa futandin
oto sa nako be mu Sikes restaurant
dafa na janna mu yat ni manje dorom bijam
aban
Sikes restaurant known for best quality food and customer satisfaction.